All right, welcome in. I just wanted to make a quick video to illustrate how to do some of these density calculations. So we have two example problems here. First one is about a gold colored pebble. We measure its mass, we measure its volume. We want to determine what the density is. And then since density is an identifying characteristic for a given material, we can try to determine, well, is this pebble gold? Yes, no, possibly. So we can use our density formula. The density is equal to the mass divided by its volume. And so this is straightforward enough. We have our mass, 23.2 milligrams, and we have our volume, 1.20 cubic millimeters. And so if we punch this into our calculators, we can just get an answer. Here we get 19.3. And our units are milligrams divided by cubic millimeters. We can try to compare this with our known value. Our known value for gold is 19.3. Oh, perfect. But different units, grams per cubic centimeter. So the second part of this question is actually going to be some unit conversions here, trying to figure out, well, can we switch the units of this value that we calculated so that we can compare maybe apples to apples with the value that's given up here in the problem. So let's do a couple calculations, a couple conversions here. We want to fix the numerator and the denominator. Doesn't matter which we do this, what order we do this. So let's just fix the top first, then let's fix the bottom. So we want our numerator to be grams instead of milligrams. So let's add one extra conversion factor for that. 1 gram contains 1,000 small milligrams. And now, okay, great. Milligrams divided by milligrams will cancel. We want to fix our denominator as well. So let's add another conversion factor, canceling out cubic millimeters and dividing by cubic centimeters. I haven't added the exponent yet. Remember, when we're dealing with units with exponents, we need to be very careful about our conversion factors. If we're just thinking about millimeters and centimeters, well, we have 10 millimeters for 1 centimeter. Since we have cubic centimeters and cubic millimeters, that means we need to cube our numbers as well. When we have millimeters cubed divided by millimeters cubed, great, those will cancel. The only units left behind, grams divided by cubic centimeters. That's what we want so we can compare with our known value. We can punch this into our calculator. Well, actually we can save ourselves some time. 1,000 and 10 to the third are the same number. A number divided by itself, just 1. So what we get, actually life is easy here. Different units, but the same value, actually. Grams per cubic centimeter. So is this pebble gold? Well, we haven't determined that it is exactly gold, but it at least has the same density, so there's the possibility that it is gold. We haven't disproven that our gold-colored pebble is made of gold. Right? At least some evidence to support it. All right, one more question down here. We have 23.5 kilograms of ethanol, and we want to measure the volume of this ethanol. And what we know is the density is 0.789 grams per cubic centimeter. So we can try to set up a plan here. We can start with our value in kilograms. We can use our density to go from grams to cubic centimeters. So maybe we need to go from kilograms to grams, and then we can get to cubic centimeters. They're asking for the volume, which cubic centimeters is a volume, but we're asking for it in liters. So maybe let's go to milliliters and then to liters. So here we go. Kilograms to grams, grams to cubic centimeters, switch over to milliliters, and then lastly, get to liters. 4 arrows in our map means we're going to have maybe 4 conversion factors along the way. 23.5 kilograms, that's our starting value. Let's get those conversion factors set up. We said we're going to need 5 of them. Three, 4, 5. All right, this first one, this is relatively straightforward, canceling out kilograms, trying to get to grams. This is the metric system. I always like to ask which of these units is bigger. Well, a kilogram is much bigger than a gram. In fact, we need 1,000 of these small grams to equal 1 of our large kilograms. Let's go from grams canceling out to get cubic centimeters in our numerator. This is the density, but the density flipped upside down. So our density is given up here in the problem. We need to think of this value as a conversion factor. So there's 0.789 grams for every 1 cubic centimeter. And that's what our density is telling us. Once we have our volume here, we can switch to just the units that we actually want. To go from cubic centimeters to milliliters, well, this is actually easy. These are identical units in terms of size. So 1 cubic centimeter is 1 milliliter. And then lastly, we can go from milliliters, canceling out in the denominator, to liters as our unit left behind in the numerator. Again, which of these is bigger? Well, liters are big compared to milliliters, which are small. We need 1,000 smalls, milliliters, to make 1 big liter. The best part here, let's make sure our units match up. Kilograms divided by kilograms, grams divided by grams, cubic centimeters divided by cubic centimeters, milliliters divided by milliliters. The only unit left behind, liters. Great, that's what we're looking for. Seems like we have this set up right. All that's left is punching this into our calculator. We can do 23.5 times 1 times 1 times 1 divided by 0.789 divided by 1,000 and get our answer, probably to 3 significant figures. All right, again, hopefully this makes some sense. Let me know if you have any questions. Thanks, everyone.